In the last video, we saw that in many cases, we can evaluate limits by just taking that x value and plugging it into our function. This also works for piecewise defined functions, and it also works for one-sided limits, which is what I want to show in this video. So here we have a piecewise defined function. It's g of x is equal to x squared minus 4 if x is less than or equal to 2. And it's defined by 4x if x is greater than 2. So I'm going to ask the similar four questions we're kind of hopefully used to seeing at this point. What's the left-sided limit? What's the right-sided limit? What's the two-sided limit? And what's the value of the function here? So notice they're all talking about x equals 2. And if I look at my piecewise defined function, that's where this function sort of changes gear. It sort of changes how it's defined. For values that are less than or equal to 2, it's defined by x squared minus 4. And values greater than 2, it's defined by 4x. Let's start with the left-hand limit first here. It says the left-hand limit. Find the limit as x approaches 2 from the left of g of x. So I want to think about what does the left-hand side of 2 look like? Are those values less than 2? Or are those greater than 2? And if you have a hard time distinguishing that, you can maybe even create a little number line and say, all right, there's 2. Values on the left-hand side over here, like 1 and 0. Are those less than 2 or are those greater than 2? Well, those are all less than 2. 1 and 0, those are less than 2. So for the left-hand limit, I want to look at how x is defined for values less than 2. So I'm going to go ahead and take that x value of 2 and plug it into x squared minus 4. So here I'm going to plug this into x squared minus 4. Here I've got 4 minus 4, which gives me 0. So there's my limit. So there's the left-hand limit. The right-hand limit, I want to say, okay, well, what's going on the right-hand side? So, okay, on the right-hand side, those numbers are all greater than 2. We're talking about this piece right here. So if those numbers are all greater than 2, I'm going to go ahead and plug 2 into 4x this time. So here, 4 times 2, that just gives me 8. So the left-hand limit is 0. The right-hand limit is 8. Part C asks for what's the two-sided limit. Well, the left and the right-hand limit, those are two different numbers. They're not equal, so that does not exist. Lastly, for part D, I want to find what is g of 2. Well, g of 2, here I'm actually going to take 2 and plug it into my function, but I'm talking about exactly at 2. Here, I want to look for the or equal to part, if I have one. I may not have one. Here in this case, it says if x is less than or equal to 2, go ahead and take that x value and plug it into x squared minus 4. Well, 2 is less than or equal to 2. So I'm going to plug that into x squared minus 4. So this would be 2 squared minus 4. 4 minus 4, that gives me 0 once again. So these are a nice practice. They really kind of flex some of those muscles about thinking about, okay, what does the left-hand side of an x value look like? Is it greater or less? Same thing for the right-hand side. And then comparing your left and right-hand limits.